And so what better person to talk about the eclipse of 2024 than with my good friend, Stephen Meeks. So welcome, Stephen.
Thank you for having me, Congressman.
And I think you're going to share the slides and kind of walk us through. Do I need to put these on to see the slides, or is this?
No, those probably won't work for the slides, but definitely got to have it handy for the big event.
Exactly.
Yeah.
Well, I'm so glad to have you. Let me turn it over to you.
But first off, because we are talking about the sun, everyone knows that it is never safe to look at the sun. Not even with sunglasses. Believe it or not, sunglasses, they're great for regular looking around. They're not designed for looking at the sun. So you actually do your eyes more harm than good by looking at the sun through sunglasses. And so they're just not designed for that. So in order to safely look at the sun, you've got to have your certified solar eclipse glasses. Just a comment on this, make sure that you're getting them from a reputable source, because unfortunately, as in past eclipses, there have been people who have made some shady products available, and people bought them in good faith, watched the eclipse, and have permanently damaged their eyes. And so make sure you're getting them from a good source, and that they are ISO 12312 certified. The other thing you can use is a number 14 shade welding glass. Make sure it's a number 14 density, and that's another way that you can safely view. But if you don't have those two, don't look at the sun. I've read accounts of people who 20 and 30 years ago, they didn't take this seriously, and didn't take the proper precautions, damage their eyes, and they're still paying for it today. And unfortunately, with our eyesight, there are just no second chances. So just make sure you're using proper solar safety. This is one of the greatest events you'll ever see in nature, and we want to make sure everyone can enjoy it without harming their eyes. So moving forward, everyone knows the moon goes around the Earth. But what we're looking at here, the moon's orbit is tilted 5 degrees to the ecliptic, and the ecliptic is just the path that the sun follows across the sky. And so the moon spends 2 weeks above the ecliptic, then 2 weeks below, 2 weeks above, 2 weeks below. And so the majority of the time when it's moving past the sun, it's above it or below it, and we don't see an eclipse. But if the moon is crossing the ecliptic at the same time the sun is there, that's when we get a solar eclipse. These occur about every 6.5 months. We have what are called eclipse seasons. And when we have one of these eclipse seasons, there has to be a lunar eclipse and a solar eclipse. So every year, there's at least 2 solar and 2 lunar eclipses. So here, coming up in about a week or so, there's actually going to be an extremely poor lunar eclipse coming up. With that very poor lunar eclipse sets up the incredible solar eclipse we have. And that's kind of the trade-off. You have a real good lunar eclipse, you get a poor solar eclipse, and so on and so forth. So that's kind of the orbital dynamics of that. Now, the moon orbits the Earth to the east, which means if you go outside and you're facing south, the moon is moving from right to left in its orbit around the Earth. So on eclipse day, when you're looking at the sun, the moon will begin to bite in from the right, and because of that tilt, it's going from the bottom of the ecliptic to the top, so it's moving up and to the left. So on eclipse day, as you're looking at the sun, look to the bottom right corner. That's where the moon will start to bite in. And on the screen, you can see here, I've got the Stellarium 23.4. This is the software package I'm using to show these slides. It's available for free, so anybody can download this and simulate everything I'm about to do. The timestamp I have on here, it's approximately 12:30. I didn't put exact times because the exact times vary across the state by about 15 minutes. So these are just rough numbers. So roughly around 12:30 is when the eclipse will begin here in Arkansas. Take about an hour and 20 minutes later, and I've stopped it here. This is about 1% of the sun's surface remaining for a couple of reasons. First off, 1% of the sun, even though it is still, it's gotten dim, you'll be surprised at how far that 1 little percent of sunlight goes. And so at this point, still too bright to take your eclipse glasses off. The other reason why I stop it here is a lot of people, they've seen a partial solar eclipse and they don't understand what the big deal is about a total solar eclipse. I mean, it's going to get dark for a few minutes. What's the big deal? Um, the difference between a partial eclipse and a total eclipse, kind of like I tell the third graders, it's like the difference between getting an ice cube and getting an ice cream. Ice cube's kind of cool and all, but the ice cream, I mean, that's where you get all the flavors, the textures, the sugar, the sprinkles, the peanuts, or just whatever else you put on your ice cream. And if you've got a 99.5% partial eclipse, you miss the ice cream. You've got to be in the path of totality in order to experience all the wonders that this brings. There's a reason why people are paying $1,000 a night to come to Arkansas to enjoy this. They're not crazy. It is that for someone, if you've not seen it, that kind of the closest thing I can relate it to, it's kind of like falling in love for the first time. I mean, you can describe what it's like to fall in love, but it's something you kind of have to experience for yourself. Same thing with the total solar eclipse. It is one of the most incredible things in nature, but you only get to see it as if you're in that path of totality. So most of second district is in that path, but if you're outside the path of totality, if you have the opportunity, I would highly encourage you to make that short trip into the path to experience this. So what will we start to see here around this time? So the lighting will have dimmed enough that things are going to actually start to turn gray and take on kind of a silvery type of appearance. Our eyes are going to begin making the transition from day to night, and our night vision is mostly grayscale. And so, especially the reds, kind of a fun thing you can do is somebody in your family wear red, somebody else wear green. The reds will start to appear gray, but the greens will actually become more vibrant. It's just the way our eyes work. So look for that to happen around this time. The other thing that you'll notice is if you look to the southwest, you'll begin to see a darkening in the sky. That is the umbra. That's the moon's inner shadow that's going to create totality quickly approaching. All right. Right before we do get to totality, you're going to see something called Bailey's beads. So the limb of the moon is not completely smooth. There's mountains and valleys, craters on the moon, just like we have here on Earth. So what ends up happening is the sun gets blocked by the mountains, but it can still get through the valleys, and so it creates this beaded appearance along the limb here, kind of like you see in the picture. This phenomena only lasts just a few seconds, but when we get to this point, this is when it's okay to begin taking your eclipse glasses off to prepare for totality. First myth about totality: it does not get dark. There's a lot of things going around Facebook talking about it getting completely dark. Join us for the 4 minutes of darkness and so forth. So it does not get dark. It's likened until about 20 minutes after sunset. You get that evening twilight. That's about how dark it will get. Now, this image is kind of a zoom out of what's going to happen. So during totality, you will be surrounded by twilight, only time in your life that's ever going to happen. But the twilight will not be uniform. Down to the southwest, it'll be darkest because that's where the moon shadow is coming from. It'll be lightest to the northeast. Now, since most of us here in central Arkansas, we are south and to the east of the center line. What'll happen is as the moon shadow moves past, the dark area to the southwest will shift off to the north, and the bright area to the northeast will shift to the south. It'll darken as it does so until maximum eclipse. And then after maximum, it'll shift over to the southwest, and the sky will start to brighten from the southwest because that's where the sun will return from. And then you'll see the moon shadow zipping off to the north and east. So watch for that changing of the twilight around the horizon as the eclipse unfolds. Now, even though it doesn't get completely dark, if you look in the slide here, next to the sun, you're going to see these two bright stars. And I'm going to kind of zoom in on what you're actually seeing there. That is the planets Venus and Jupiter. So as you're looking at the sun on that day, Venus will be the brighter one to the right. Jupiter will be to the left. You'll be able to see those without any trouble. If you look over into the eastern sky, depending on how clear the air is that day, you may see a few stars, the stars of winter. Then we got Betelgeuse, Rigel, and Aldebaran. Those are the stars in the constellations Orion and Taurus. So look for the stars. Again, it's going to depend on the sky conditions that day. Without a doubt, though, you will see Venus, you will see Jupiter. The other thing you might see is a comet. So there's a comet. It's called Pons Brooks. It has a 71-year orbit of the sun, and it just so happens that it'll be a few days away from maximum brightness around the time of the eclipse. Now, astronomers don't think it'll be bright enough to be seen during the eclipse. However, this particular comet, from time to time, is known to have an outburst. And if it has one of these outbursts in brightness during eclipse time, there is a very, very, very tiny possibility that the comet could be visible during totality. So, again, probably not, but look over there by Jupiter. We may be surprised. You can see a picture there in the bottom left. That's actually a photo I took of the comet here about a week ago. And so if you live somewhere dark, it's currently visible in binoculars over in the western sky. And as we get it closer to eclipse day, it may get bright enough that you'll be able to see it with your eye from a dark location. But again, probably not, but I do point it out just because that would be like icing on the cake to see a comet during. Yeah, the corona is the outer atmosphere of the sun. So the surface of the sun is about 10,000 degrees, but as the gas and plasma flow away from the sun, it jumps to over 1,000,000 degrees. We still don't fully understand why that happens, but it does. And so what you're seeing there are the white hot gases in the outer atmosphere. Again, this is the only opportunity we ever have to see it from the surface of the Earth. So this is part of the reason why NASA will send scientists and astronomers into the path of totality, because this is their only chance to directly observe and study this from the Earth's surface. So I think there's going to be a few of them over in Russellville to take advantage of it. But the corona is about the brightness of the full moon, so no eclipse glasses needed for this point. And as far as what we'll see, it's anybody's guess. It just depends on what's going on with the sun. We're in a very active phase in the solar cycle right now, so should see some streamers, maybe some, if there's a coronal mass ejection, maybe a loop or two. Again, anybody's guess, but look for that ghostly white glow of the corona. Other things you'll see during totality, just in the environment around you, is the birds are going to stop singing. The frogs and the crickets might start. So the animal kingdom is going to react as if nightfall is coming. There's actually several zoos located along the eclipse path. And so there's going to be scientists who are going to be studying animal behavior, how they react to the drop in sunlight. Other things to notice, weather could be impacted. Back in the 2017 eclipse, when I was there for totality, the wind directions actually changed during the eclipse. Temperature can also be influenced as well. Not a whole lot, but there is a cool area in the shadow of the moon. And so you might see if you can take note of that. The last thing you can kind of look for is if you look in the trees, nearby, underneath them, the leaves will act like little pinhole cameras. And so if you look underneath the trees, you'll see dozens and dozens and dozens, of little eclipsed suns shimmering on the ground. So that's kind of a cool effect to look for as well. And of course, if you're in a crowd of people, listen to how they're reacting as well, because that can be one of the fun things to observe. All right. So just as we had the Bailey's beads to begin the eclipse, we'll have them to end. And then there's going to be this bright burst of sunlight as the photosphere comes back out. So this is called the diamond ring effect. It happens on the way in, but it's a lot more difficult to observe, a lot easier on the way out. So the diamond ring effect, what this is the glow of the corona. That's the ring, if you will. And then that bright burst of sunlight is the diamond. That is the sun coming back out. And that is your cue to put your eclipse glasses on, because that means totality has come to an end. This is the longest total solar eclipse that has come to the United States since the 1830s. First one in Arkansas since 1918, so been over 100 years. And evidently, according to news accounts, it was cloudy back then, so hopefully we have a little bit better luck than they did. And we will not have another one until 2045, so a good 21 years from now before our next opportunity. Now up here, I've got a map of Arkansas showing the path of totality. That blue line in the middle, that's the center line. So that's when you get the maximum length of totality. So down near DeQueen, it's 415 or so, and drops to a little less as you get to northern Arkansas. And a lot of people will want to focus on that line, but if you're within 20, 30 miles either side of that line, you're going to get 4 minutes plus. So, if you're coming up 65 in my direction, if you're anywhere between about Greenbrier and Marshall, you're going to get about 4 minutes. Same thing, Morrilton over till Russellville. So don't focus on getting exactly on that middle line. If you're anywhere within, like I said, 30 miles either side of that blue line, you're going to get a good 4 minutes worth of totality. The other thing I want to point out while I've got this map up is because this eclipse is going to be one of the longest ones we've had in a while, and we will not have another one for 20 years. A lot of people, of course, are planning on coming to Arkansas. Difficult to know exactly how many, but estimates are 300,000 plus. And there's going to be a lot of people who are going to come early. They're going to be camping out. But there's also going to be a lot of people who are going to be driving up the morning of the event. During the 2017 eclipse, I stayed about 2 hours outside of the eclipse path and then drove in the morning of. And so probably about half of what we're going to see is going to be people driving in that morning. And then they will drive back after the event is over. But regardless, there will be more people in Arkansas on that day than there has ever been in the history of our state. So huge opportunity for our state. So as I said, 300,000 people, 3 people per car, that's 100,000 extra vehicles on the road. Now, that is assuming all things equal. So what I mean by that is the weather in this region is clear all the way around. State of Texas is expecting over 1 million people. If it is cloudy in Texas, guess where all those people are coming? If it's cloudy to the north of us, those people are coming this way. And so those situations, you're looking at over 1 million additional visitors to the state of Arkansas. And that's where, concern starts to build for our infrastructure capabilities. But what I'm telling folks is, Wednesday, Thursday beforehand, go ahead and get gas for your vehicle, because all those people who are traveling are going to need gas. A lot of people are going to be here camping, and the people that are here camping, when they go to, Walmart or Kroger or wherever, what are they going to be after? Well, think camping supplies. They're going to be after, s'mores and hot dogs and chili and dried goods. They're not going to be buying frozen TV dinner, stuff like that. So anything that's related to that you'd like to have, get that stuff probably early. The other things, like I said, frozen dinners, there's probably not going to be a rush on that stuff. Be aware there's going to be a lot of traffic talked about. Excuse me. All those cars on the road. So just plan your day accordingly. If you have a way to take back roads to kind of stay off the main thoroughfares, please do so. The Arkansas Department of Transportation obviously understands this situation, so they are going to have all, as best they can, they're going to try to have all road construction on hold for that weekend to allow the lanes to be open and as clear as possible. Cell phone carriers, same thing. If you've got 100,000 people all trying to live stream the eclipse to their friends back home, obviously that's going to create a issue with cell phone carriers. Those folks are they've been through this before with past eclipses. They'll have additional resources in the state to be able to handle that. The Arkansas Department of Emergency Management will be fully staffed during this time period. They'll have resources deployed across the state police, highway patrol, all that. So this has been well thought out, planned. And so, this is actually a chance for Arkansas to shine. There's going to be a lot of people that come to our state for this that probably otherwise would never come to Arkansas. And so this is a great opportunity for us to share the beauty that we get to enjoy every day. And maybe encourage them to come back when it's maybe a little less busy. The economic side of this, you get 300,000 people and they spend $100 each. That's, $30 million. They're probably going to be spending a lot more than that. So the economic impact, especially if we end up with the million plus visitors, we could be talking $200-300 million economic impact to the state. So this could be a huge boon to our businesses, and of course, and that'll filter through the rest of the economy. So hopefully, it'll be clear here, so we can take best advantage of that. Just a few last thoughts I'll throw out, and then if we've got time, Congressman, if we want to do questions, we can. But don't use your cell phone to try to take photographs of the partial phase. Your phone's not designed to do that, and you can actually potentially damage your phone. There are filters that are available for that, and actually, you probably won't be happy with the results anyways during the partial phases. Now, when we get to totality, snap away, take all sorts of pictures. I've had people who've worried about their pets and dogs and stuff like that. Their dogs and cats, they're going to have no clue or no interest in what's going on in the sky, so no worries there. Make sure you keep close eye on children, especially if you're going to have any optical instruments around. I know, like myself, I'm going to be using telescopes, and I'll have binoculars to try to photograph this eclipse. If there's any young children around, please pay extra close attention to them. Again, just finishing up, do not risk your eyesight. And of course, probably the most important thing is make sure to take time just to stop and enjoy it. Those 4 minutes are going to happen extremely fast, and I know folks are going to want to take pictures to remember, but make sure just to block out 30 seconds to a minute just to take in the majesty of everything that's going on.